Hi, this is Sanjay Gangal from MCADCafé. I'm here with Byron Kennedy, CEO of Speed 3D. Or do you call it Speed?
Speed 3D is what we call it, but it's a hard one.
Okay, and Byron, we talked last year, and you talked about a lot about your company and stuff. Now I understand you got a new large format printer being announced, Titan Speed 3D. Tell us about that.
Yeah, so this is our new printer that we've just released only this week. So Titan Speed is using our deposition technology, a technology called cold spray, but it's now scaling up. So to date, we've been building parts up to, let's say, luggage size, up to 20, 30 kilos, 40 kilos, so, roughly up to 100 pounds. But we got requests over the last, 2 years saying, we want to build much larger parts. So think of, parts for ships, think of parts for submarines. These are 2,000 kilo parts or 5,000 pounds, and much bit larger. Let's talk about 2.5 meters. So that is the request we're going. So we worked over the last 18 months to develop this new technology to be able to build much larger parts, much heavier parts. And we've released that now and very excited about the opportunities that brings.
That's massive. That's pretty massive. I guess the name Titan is justified here. So your technology is being deployed by various defense forces, including the British Army. How do you see this technology evolving to meet the specific needs of military applications in the future?
Yeah, so one of the bits of feedback we got from the military, we've done a lot of work with the military since about 2019, 2020. So let's say 5 years. We deployed some of our earlier systems, and the feedback came is these were just straight 3D printers. But they're like, actually, we want to do everything in the field. So we want to be able to print, but then we want to be able to heat treat. We want to be able to machine. We want to be able to test. So what we developed is a 2 shipping container platform. So 2 20-foot shipping containers, one with the printing and one with all of those accessory elements that I mentioned, machining, heat treating, testing, all that sort of gear. Those systems now go into the field together, and that's enabling defense to build complete finished parts. So going from CAD or going from a concept. So when a soldier comes along and says, I need this specific part, bracket, whatever it may be, they can then design it, print it, heat treat, machine it, test it, put it on the part and have confidence that it'll work. That is now the future of 3D printing. And it's not just the printer. There's no use actually deploying a printer with the military. Really what they want is the final solution. So it's the whole solution, which is very important.
Okay, and does it have commercial applications as well, I assume?
Yes, indeed. Yeah. So commercial, and even if you look at the expeditionary, so where does expeditionary fit in the commercial world? Well, think in remote areas. Think about mine sites. Think about oil and gas. Think about marine. They actually all have the same problems as defense, which is I need a part because my oil and gas rig is down or my conveyor belt for my mine site is down. Now, different needs, that for those mining and oil and gas customers, it may be it's $1 million an hour if their site is not running. So having the ability to get their part, even an hour quicker or a day quicker, the economics justify being able to have this equipment on site in the field, being able to get them back running quicker. So defense have a different need, but still about getting parts quickly at remote locations.
Okay, and you also come up with a new material called nickel aluminum bronze. Tell us about that.
Yeah, so nickel aluminum bronze is our latest material. This is specifically interesting for the marine sector. So let's say in defense, it's Navy, but also in commercial applications. So the interesting thing about the material, it's been used in conventional manufacturing for a number of years. In those sectors, it's highly corrosion resistant, especially for seawater. So if you've got an application which is under the sea, in the water all the time, you'll often use the material. So if you that material is a gold-like color. So if you look at propellers on big ships, you'll always see this gold material. That'll be typically this nickel, aluminium, bronze. It's a high copper content material. So in general, it's quite difficult to make in conventional 3D printing. For us, it's a material which works very well, very easy for us to print, gives very good properties, and importantly, gives this corrosion resistance that they need in the marine sectors.
Okay. Can you also elaborate on the capabilities and advantages of the newly launched Expeditionary Manufacturing Unit, or EMU?
Yeah, EMU for us is really this ability, like I talked about, to be able to build these parts in the field, but also to then, for a soldier, to be able to take this finished part and go to their commanding officer and say things like, I built this part, but at the same time, I've tested the material that I built in parallel, and we know the material. Let's say they build a test coupon at the same time. They'll test that, and they can go to the commanding officer and say, I built both of these things together. I've tested the coupon; it's good. Therefore, the commanding officers can say, right, I've got confidence in that part. Put that on the truck or wherever it may be, because I know that that's a good material. That is really what EMU is enabling people to do, is to really have confidence that the parts they're building, one, fit their need, and two, is good, hardy material, which is very important.
No, the EMU is designed to be a mobile solution for producing large metal parts on site. What were the key challenges in developing such a versatile and portable system?
Yeah, so they're still they're portable, but they're still large. So 2 20-foot shipping containers is the full EMU system. Now, for people like the military, they can easily transport these 2 large shipping containers because they have the infrastructure to do that. So we knew that they could do that, and they gave us the feedback about what they were looking for. So then, as a manufacturer, we then have to have the ability to really scale up our production. So in the 3D printing world, for instance, you're looking at anything from small desktop printers, which you can buy in your local supermarket, all the way up to these full shipping container solutions. For us, we're really at the top end, building these big pieces of infrastructure, which are then moved around. And then it's then having the infrastructure internally to be able to do that, but then providing a high quality product that's really robust, because where defense is taking these applications is, they're not just going along a normal road. They're doing 6 hours bashing through the bush to be able to get to wherever they need to. So what we produce has to be robust and strong enough to really survive whatever defense is going to do to it.
No, cold spray additive manufacturing, or CSAM technology, is a cornerstone for Speed's offerings. Can you discuss how CSAM technology works and the benefits it provides over traditional metal manufacturing methods?
Yeah, so the internals of our printer uses this CSAM technology, as you just explained, cold spray additive manufacturing. So what cold spray is firing metal powder at supersonic speeds. So let's say 1,000 meters a second, or 3 times the speed of sound. So what happens is we fire this metal powder, and when it hits a surface, it's traveling so fast it'll stick. So think of a bug hitting a windshield. So you're driving along in your car and you hit a grasshopper and it sticks. That's what we're doing now, just with metal powder. And if you can control where it sticks, you can then build a part. So that's CSAM, or cold spray, has been used a lot in repair in the past. What we did is take a repair technology, added software and sophistication to control essentially where these particles are landing, and then building parts.
And since these are such large parts, I'm assuming in terms of fine granularity, or is it less granular than some of the smaller printers, and more cores?
Yeah, they're all different, of course. So I'll give you an example on our new Titan product. We just produced a part which was just over 200 pounds or about 90 kilograms. That took us about 25 hours to build that part. So so it takes a while. But when you're looking at big parts, so we're talking about 2 to 3 foot diameter kind of part, that sort of size. Usually you're not looking at high fidelity in the large parts. What's more important is quality and speed in those parts. So our process is very quick to be able to build parts. So, if you're using a traditional metal 3D printer, it's not 25 hours. It might be 250 hours instead. So it's really, or more. So it's really being able to say, right, I want to build this quickly, and I need to be able to get to the resolution that the customer's after. But generally, as I said, in the large parts, the fidelity is not important.
And would it be able to handle explosive forces like the cannon forces if you were to build a sort of tube for a cannon or something like that, and you got real explosive powders going through it in the process? Is it able to handle such strong forces?
Yeah, so the material properties of the metals that we produce, so it's all metals, so we don't do any plastics. All the parts that come out of the printers are metals. Their material properties, so their strength, their elongation, their corrosion resistance, are typically better than a cast product. So products are either cast or forged in traditional sense will always be better than cast products. And a lot of parts that you sort of mentioned could either be cast or forged, depending on what their applications are.
Okay. And Byron, what is the best way for our audience to find out more about Speed3D on the internet?
Yeah, speed3d.com, so SPEE3D.com. You'll find us, and also we're represented around the world. So we manufacture these systems in Australia, but also have teams in the EU and the US. So we're physically located all around the place. And a couple of good shows are coming up, which we'll be displaying at as well.
Okay, and are you going to be at the Rapid plus TCT conference?
Yes, indeed. So I'm sitting here today at a different show called CSAT. So this is specifically around the cold spray technology, which I talked about earlier. So quite a smaller, dedicated conference, but industry experts. And then in roughly 2 weeks, a week and a half, we'll be at going into LA and displaying at the largest 3D printing show in the US, which is Rapid. And it'll be a great event for us. So we're going to have our warp speed printer on display at the show, and we'll be printing parts. In particular, we'll be printing our new nickel, aluminium, bronze material. So people can come along and they can see us manufacturing parts. Let's say a part will be this size. It might take us half an hour to be able to build that. So, people can sit there and watch, and people often watch the whole thing because they're fascinated by the process. You can see it building in real time. And, we've gone from powder to part in, it could be 10 minutes or it could be 30 minutes, depending on what part we do. And you can watch the whole process at the Rapid TCT show. Okay.
Yeah, and Byron, last time we talked, you had mentioned that you are an avid golfer. Do you get a chance to play golf on these business trips?
Yes, I'm going out on the weekend. So I did forward plan that and emailed a couple of people here and said who's interested, and I'll usually get 1 or 2 takers. So we're going out bright and early Saturday morning. Looking forward to that because it's nice and warm here. We're back in Australia now. It's a bit on the cold side, so following the sun is important.
Okay, and last time you also mentioned that you had 2 dogs, and who's taking care of the dogs right now?
Yeah, the family is still back there, so they're in the cold with the dogs, but the dogs will be keeping them warm.
Okay, and you love traveling, and last time you had mentioned you had been to Italy and the Australian deserts. Any new trips that you want to mention since the last time we talked?
A few more trips around Australia, which I enjoyed. We went up to some islands called Fraser Island. It's a fascinating place for anyone who hasn't been there. A full sand island where you could, but it's all forward driving. So that was my last journey, but really enjoyable. Like you just said, we're over in the US now, so I've got 3 weeks over here, which I also enjoy tremendously.
Okay. Well, thank you so much, Byron, for taking time to record this interview. Have a great day and stay safe.
Thanks, Sanjay.
Okay, this is Sanjay Gangal from MCADCafé.